6.5. In 6.5, oh, that's nice. We're dealing with something called sequences. And there are actually a ton of different types of sequences, but we're only dealing with two types. The first is called, now that is the word arithmetic, right? But when we talk about sequences, for some reason we pronounce it arithmetic. Don't know why. I know. It's weird. So there are arithmetic sequences and there are geometric sequences. Okay? Arithmetic sequences are easy. We just add or subtract, and it's always the same number every time. So the pattern could be +3, or the pattern could be -7, but it's -7 every single time. And then the geometric sequence, we always multiply. Now, we could say multiply or divide, but we don't actually do it that way. How do you divide if all you're allowed to do is multiply? You multiply by a fraction. So if the pattern is divide 3, then instead of divide 3, we're just going to multiply by 1/3. If the pattern is divide 4/5, divide 4/5, the multiply pattern would be multiply by 5/4. So you just flip it upside down. So, let me show you some sequences. Here's a really easy one. 1, 2, 3, 4, and so on. What is the pattern here? What am I doing to the numbers in the list? +1. So this has a common difference, and the difference, D, is +1. So a sequence is a list of numbers in order that follow a pattern. If the pattern is addition or subtraction, we call it an arithmetic sequence. If the pattern is a multiply, we call it geometric. Okay? If I had 10, 7, 4, 1, -2, what's the pattern? -3. So D equals -3. Now, you're only going to have a little bit of arithmetic in there. We're going to focus mostly today on geometric. And geometric is a little bit harder. So let's say my pattern is 3, 6, 12. What's the pattern? Multiply by 2. Now, a lot of you guys are working on something. Look up here, please. This is going to get a little bit tricky. So the pattern, we call it a common ratio. The ratio is 2. So 3 times 2 is 6. 6 times 2 is 12. What if it says, find the next 3 terms? What will they be? Good. 24, 48, and 96. You guys understand that? Now, when we have a geometric, or any kind of sequence really, we call the first term 1. And every sequence is given a letter, like this could be A sub n. So the name of this list of numbers is A. So the first term is called A1. But when we do exponents, that's called a superscript. We list the number higher, that's called a superscript. If we list the number lower, it's called a subscript. So we call this A sub 1. And the next one is called A sub 2, A sub 3. Well, what if I wanted to find term 11? What would the 11th term be? How would you figure that out? You could just push enter on your calculator, right? So I could say the first term The first term is 3. So times 2. That's term 2. 3, 4, 5, 6, 7, 8, 9, 10, 11. The answer is 3072. Does anybody see a problem with that solution method? That wasn't too bad, right? Maybe you can't count. What if I asked you to find term 375? Oh, we might run out of room. Yeah. Okay. So how else could we figure that out? So if if this term is a sub 1, how many multiplies by 3 do I need to get to 11? I need 10 more. Does everybody understand that? If I'm sitting at a sub 1 and I want to reach a sub 11, I'm going to do multiply by 3 a whole bunch of times. How many times? 10 times. If I'm at 1 and I want to get to 11, that's 10 threes. So what you do, or 10 twos, sorry. 3 times 2, how many times? To the 10th. Does that make sense? That's the pattern. The pattern is 2 times by 2. So to get from 3 to 6, I times by 2. So if I want to skip straight from here to 11, then I need to do multiply by 2 10 times. And watch this. 3 times 2 to the 10th jumps me straight to the answer. Does that make sense? Okay. That's just about everything we need. Let's work some of the problems in the assignment. 6. So the first problem says, what are the next 2 terms? What's the pattern here? So is geometric add or multiply? Multiply. So we need to find a multiply pattern. How do we get from 8 to 16? Times by 2. So what would the term after 32 be? 64 times that by 2, 128. Piece of cake. Piece of cake. Okay, this one looks a little trickier. How do we get from -5 to 10? Times by -2. Good job. So what comes after -20? +40, and the next one? -80. Okay, what if it was this? That's a bad idea. What's the pattern? Good. It looks like divide by 2, which it is. But when we're dealing with sequences, we never talk about division. We always talk about multiplication. So how do we get from 80 to 40 using multiplication? Times by half. So what would the next 2 numbers be? 10 and 5. Okay? So in this one, you need to state, is it arithmetic, or is it geometric, or is it neither? What pattern do you notice with the first one? You guys recognize a pattern? Add 4, so that would be arithmetic. Good. Pattern for the next one? And divide by 2 is also known as times by a half, so that one's geometric. Why neither? Good. So we divided by 5, and then times by 5. So it's not the same pattern, so that one would be neither. Okay. All right. Is the first one geometric? Yes or no? Yes. What are we multiplying by? Timesing by 1/2. So we would mark this one as geometric. Oh, sorry. Mark it as geometric, and the ratio is 1/2. Okay, the next one. It's times by a fourth, times by a fourth, times by 4. So that one's not geometric. And the next one is subtract 3. So it is not geometric. Okay. And the last one. This is where it gets a little bit tricky. What is the pattern here? Times by 2. Okay. If this is term 1, b sub 1, how many times by 2s do I need to get to term number 12? 11. So I will take 10, and then I'm going to multiply it by 11 2s. The faster way to do that is this. 10 times 2 to the 11th. Does that make sense? All right, that's it. Get to work.